So now is our journey into looking into exponential functions continues and dealing with a lot of financial information. Now we're looking at depreciation by a fixed percentage. Really, the only difference between this and compound interest is that now we're looking at situations where instead of having a growth by a certain percentage rate like we do in compound interest, we're experiencing decay. So it's declining. Um, and the other thing about it is typically we're looking at a value of m that is going to be equal to 1, since it's not gonna be like depreciating by 4% over the course of we just look at the annual amount. So we don't worry so much about a compound value of m. So so it's basically the same formula. The only thing we have to keep in mind is that since I'm going to be declining by a certain percentage, my value for r is going to be considered to be negative because I'm losing a percentage at that point. And that's what this all kind of gets into, and also this talks about that as well. So I'm expecting to see, a decline, And one of the things that often gets depreciated is like cars in particular, but there's other things that, like computers, office equipment, and things like that that you can also claim on taxes. That you go through a depreciation model to like kind of know how much, you're losing money on this piece of equipment or car or whatever. So, how do we make use of this? Just so you know, for future reference, I mean, not so much in this course. I mean, you'd probably be saying, okay, here it's being depreciated by this amount. How much is it worth after a certain period of time? There are some other, like, economics terminology that might say it's a declining balance method of depreciation instead of, or it's an accelerated depreciation. Because basically the whole premise behind it is I'm losing the same percentage each year, but the amount of money I'm losing each year is going to be declining, because if I start with $10,000 and I lose like 5%, I'm losing. Give me a second. I'm losing $500. So that means I'm going to have $9,500 the next year that I started with in value, and then if I lose another 5% from that year I'm only losing $475, and that's going to keep happening over and over. So basically, it's the same percentage each year, but as far as dollar total, it's going to be a different amount because it's going to be me losing less each year overall. So. So as an example, a car worth $15,000 depreciates in value by 40% each year. How much is it worth after 3 years? So, since the car loses 40% of its value each year, that means it's equivalent to an interest rate of negative 40%. So when I apply the compound interest formula, I'm using the fact that I'm going to have, A equals 15. Well, I'll put the A equals here. And I don't need it in another position at all. So let me get rid of that. A is going to equal 15,000 times 1 minus 0.040, of course, over 1. And one of the things that you want to keep in mind, because as we do it, it says other exponential growth and decay models. Whatever formula we end up with, it's always dealing with the amount we have, not the amount we lose. Okay? So that's why eventually in here, I end up with 60% occurring there, because if I lose 40%, I have 60% left. So the formula is always going to deal with the amount I have present, not the amount that I'm losing. So if I calculate this out at this point, I get about $3,240 approximately. So basically, this function here would give us the car value after X years of depreciation. And again, I want you to notice that the yearly loss of 40% means that 60% of the value is retained. And that's what ends up in the formula. It's the amount we have or the amount that we keep. That's what ends up in the formula. Because I have a lot of students that would say, they would set up a problem like this and they would say 15,000 times 0.40 to the x power. And, it would be depreciating a lot more significantly at first and make the value a lot less at that time. So, now it's your turn. I'm going to have you answer a very similar question. A Toyota Corolla automobile lists for $19,700 and depreciates by 35% per year. Find its value after 6 months and find its value after 4 years. I'll give you a moment or two to figure it out. Okay, so our starting amount or starting value for this car is $19,700. I'm losing 35% per year. So when I use I need to come up with a formula that describes the decaying of its value. So I'm going to start with the compound interest formula. The final amount is going to be $19,700 times 1 plus a negative 0.35 over 1 to the 1 times t power. So essentially, since I'm losing 35%, I am keeping 65%. So this is the formula I'm going to be using for the rest of this problem. And you're going to find that in a lot of exponential type problems, one of your goals is often going to be taking the information that you have and coming up with a formula or a model that describes the growth or decay, whichever in this case it's a decay, so that you can just plug the numbers in the right places to solve it. So in this case here, after 6 months. Now, since everything here is dealing with years, we have to make sure that we're putting in a value of t that represents years. So 6 months, I don't want to put 6 in for t because 6 months is, if I put 6 in, that would represent 6 years. I have to realize that this is half or 0.5 years. So when I plug that into the formula now, I'm going to have 19,700 times 0.65 to the 0.5 power. And when I evaluate that and round off, it's the only place I am rounding, to 2 decimal places, I get about $15,882.65. So in 6 months' time, it's already lost close to $4,000 in value. So the next one, 4 years. Now this one's a little easier because I'm still using the same formula that I put in the green box next to there. The only thing that's different now is I'm putting in t to be 4. And when I calculate that, I get about $3,516.57. So that's what the value of this Toyota Corolla will be after these periods of time based on the information we have. And that's the end of this example. So if you have any further questions, please make sure you ask about them in class. I'll see you around.